Hello and welcome to Shourav Sir's classes. If you like our video, do give us a thumbs up, and if you want more, you can just visit us as www.shouravsirclasses.com classes.com. Or if you just want to say hi, just drop in a text message or WhatsApp us on 98367930766. Links are in the video description. Okay, so we will be starting by solving some problems on logarithms. And if you want to watch the theory behind logarithms, you should visit our lectures. So let's get started to it. We are given this expression, which is log x by L plus m minus 2n. This is an n by equals log y by m plus n minus 2l equals log z by n plus l minus 2m. And then we are required to find x squared, y squared, z squared, y squared, z squared. Now what we do is we just observe that the denominator terms are in what is known as a cyclic order. This is called a cyclic order. We call this so because they switch places with each other once each term is we observe. So what we do here is log x, hang on one second, log x by L plus m minus 2n equals k. This k is a proportionality constant and it's arbitrary whatever k is. And similarly we write log y by m plus n minus 2l, which is equal to k again, and log z by n minus l, n plus l minus 2m. So once we have this, we just equate this with k again, and we just transpose this denominator to the right hand side, as we all know. So log x equals k into L plus m minus 2n, and log y equals k into m plus n minus 2l, and log z equals k into n plus l minus 2m. Once we have done that, we just go back to the sum and note that we are required to find x squared, y squared, z squared. So what we do is we take log xyz, and since we all know is equal to, according to the formula, L plus m minus 2n plus m plus n minus 2l plus n plus l minus 2m. Now if you have a sharp eye, you will note that every term cancels each other out, and we are left with log xyz equals to k into 0. Let me just insert a new page and then we'll proceed. Right. So once we have done that, we just write it again, log xyz equals to k into 0, since every term cancelled each other out in the last statement. Now we take the anti-log on both sides, which means that we have xyz equals e to the power k into 0, and xyz equals e to the power 0, since anything multiplied by 0 is obviously 0. So xyz equals to 1, since anything to the power of 0 gives us 1, and so x squared, y squared, z squared equals to 1, and we are done. Right, now we proceed to the next question. Just hang on. So what we have, okay, so we have here 2 into log a plus 2 into log a squared plus 2 into log a cube plus dot 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 2 into log a n. Now we note that this expression forms a type of series or a sequence if you're too technical on stuff. And we note that we can collapse this entire expression and write it as a product. We do this as 2 into log a into a squared into a cube, and this goes on until a n. And when we evaluate this, we have 2 into log a, and we just add all these powers. Since the multiplication of the same base, we add the powers. This is a simple law of exponents. We have 1 plus 2 plus 3 and dot 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 n. So we have 2 into log the base log a base and exponent n into n plus 1 by 2. And then once we have this, by the law of logarithms, we can write 2 into n plus 1 by 2 plus 1 by 2 cancels out, and we have log a. So we get your answer as n into n plus 1 log a, which is B. Right, so we proceed to the next sum. Okay, just something, a food for thought, that if you want to pause my video at any time, you can do so freely and then go over if I'm going too fast, and I don't think it will be a problem. But if you have a problem, just pause my video and then rewind and then just watch it again. Okay, let's proceed to the next sum. And I'm having problems scrolling this page down now. Okay, here we go. Right, we can turn over now. Right, so this is the problem we have in hand. We have log to the base 3. Just note that the base changes now. Log to the base 3, log to the base 3 2, log to the base 4 3, log to the base 5 4, log to the base 15 14, and log to the base 16 15. We are required to evaluate this entire expression. So what we do is, we can write log to the base 3 2 as log 2 by log 3, log 4 3 as log 3 by log 4. And if we continue like this, we can write, no matter how long this expression is, we can always write, in this case, log to the base n plus 1 is and n equals log n by log n plus 1. Now if you have a sharp eye, you will note that since these are multiplied together, every other term just cancels out. How? We just, let me just give you like two examples and you will just catch what I'm saying. Log 3 into log 3 by log 4, and you'll note that these two cancel out, and again log 4 by log 5, these two cancel out. Similarly, so what we are left with is, eventually in the end, since every term cancels each other, and then we are left with let's just see this here, log 15 by log 16. Now 15 will cancel out with the previous term. Let me give a dot dot. Yeah, right. 15 will cancel out with the last term, log 15. So what we are left with is log 2 by log 16. Right? Now again, we can write log 2 by log 2 to the power 4, since 16 is 2 to the power 4, and we apply the law of logarithms again, log 2 by 4 into log 2. Again we can find that these two cancel out, so what we are left is 1 by 4. Right, let's see if we have an option 1 by 4, and it's correct. You can see how this bigger term just gives a very small answer. This is a very clean answer. This is what is called a very good sum, right? So moving on, we have, let's see the next sum. Oh, this is pretty important, right? We will have, the question demands a cube plus b cube equals 0. Then the value of log a plus b minus half of log a plus log b plus log 3 we are required to find. Now, if you look at it from a layman's perspective, you will be perplexed whether how you will integrate or how you will take a and b from this a cube plus b cube and incorporate that into log, and then you'll have to find out the answer. It is not at all that perplexing. Let me just tell you this. The trick is, if you just take a plus b whole to the power cube and just expand these terms, we will have a cube plus b cube plus 3ab into a plus b. We have a cube plus b cube will cancel out to give 0, since we have already this provision here. Now what we are left with is a plus b whole cube. Let me give an implied sign, and this is equal to 3ab into a plus b. Now here's the trick to the question. Just take log on both sides. Take log on both sides, and we'll have 3 log a plus b equals, we have equals log 3 plus log a plus log b plus log a into b. I mean a plus b. Now you might be thinking, why am I writing it like this? Because if we take the product, and then if we have a product, this is a product, and then if we take a log of that product and expand that log, we will have log, for example, log xyz can be written as log x plus log y plus log z, right? And then we note that here we have a 3 log a plus b, here we have a log a plus b. Now what we do is, we take this thing to this side. Simple. So we have 2 log a plus b equals log 3 plus log a plus log b plus log a plus b. Oh, I'm sorry, this a plus b was already taken. Hang on, so I'll have to rub that bit out. Right, just right. So here's the expression we have, and then we take this 2 and then we just do a 1 by 2 from here and log 3 plus log a plus log b. Just simply transposing this from the left hand side to the right hand side. Now we have log a plus b minus half of log 3 plus log a plus log b, which is the required expression, and this is eventually 0 because the right hand side is 0, since we have transferred this to the left hand side, right? Plain and simple. So we have the answer 0, right? Moving on to the next one. We just push it up again, right? Let's see what the next sum. Job, Baba. Right, let me just pull this up, and here we go. So what we are required to find is, we are given that a squared plus b squared equals to c squared. Then log to the base c plus a b plus log to the base c minus a b. We're required to find this expression, and right, this may look completely out of the world, but the trick is we write this as 1 by log b by log c plus a by the law of logarithms, 1 by log b by log c minus a, and we just flip this since we take the reciprocal once we have this structure 1 by x. So we have 1 by x, so this will eventually give x. So we have log c plus a by log b plus log c minus a by log b. And now since we have a common denominator, no need to take the LCM, so we have c plus a plus log c minus a by log b, and we have, let me just get a new page and we'll continue. Just insert page here, right? So we have log c plus a by plus log c minus a by log b, and by the law of logarithms we can write log c plus a into c minus a by log b. which will give us log c squared minus a squared by log b. Now if you look at the question, we have the given condition. Let me just show you. We have the given condition a square plus b square equals to c square. So what we have is c squared minus a squared log of c squared minus a squared by log b squared, or log b, sorry. So we can replace this as b squared, since c squared minus a squared, once we transpose this a and take this over this side, we have b squared. So let me just scroll it up, and right, we can replace this as log b squared by log b. Now we can simplify this and write it as 2 log b by the law of logarithms, and log b gets cancelled, so we are left with 2. Another example of a very good sum, because the expression, if you just see, it looks pretty bad, and we get a very small and simple answer, a 2. So this is an example of a very niche type of sum. So let me just move on to the next, scrolling it up, and all right, we have log to the base 8 17 by log to the base 9 in 23 minus log to the base 2 root 2 by log to the base 3 23. Fine enough. This will be a very clean answer. You can already tell, since the options are pretty simple. So what we do is, we evaluate this as log 17 by log 8 minus log, divided by log 23 by log 9, the base, and we subtract it, log 17 by log 2 root 2 divided by log 23 by log 3. Fine enough. So we just need to evaluate this. We can do this as log 17 by, let me just write it more clearly so you can understand it better. This division sign will be a problem now. Log 8 by, a big by, and we have log 23 by log 9, and we negate log 17 again by log 2 root 2 by log 23 by log 3. Now you can visualize this as, let me just grab a new page, hang on, insert page, right. We have log 17 by 3 log 2 divided by log 23 by 2 log 3. minus log 17 by log 2 to the power 3 by 2, since log 2 root 2 is 2 to the power 3 by 2, by what did we have there? Right, we had log 23 by log 3, which is equal to 2 log 17 to the base 2, since this comes up here, and divided by log 3 log 23 to the base 3 minus 2 log 17 to the base 2 by 3 log 23 to the base 3. Fine enough. Similar terms, they will cancel each other out and then they'll give a very sweet 0. So again, a very niche sort of problem. So we move on to the next one. And right, let me drag this down, and we have log to the base e. Now remember, log to the base e is also called a natural logarithm. A natural logarithm. It is also called a Napierian logarithm. Napierian logarithm. This term looks like it will be used in a spell bee. In any case, that is Napierian logarithm, and we are required to find log to the base e a squared minus 4a plus 5 equals 0. Then we are required to find a. Fine enough. We take the anti-log on both sides. So we have a squared minus 4a plus 5 equals to e to the power 0, and a squared minus 4a plus 5 equals to 1. So it burns down to a simple quadratic, which is a squared minus 4a plus 4 equals 0. And it is not necessarily a quadratic, it's sort of like in a whole square form. So can we write a minus 2 whole squared equals to 0? So what? A equals to 2, and that's your answer. And that is option number B. A equals to 2. Moving on to the next one, we have, right, so what we have is, all right, this one. So we have log 49 root 7. So we can generally guess that this has something to do with 7, and log 25 root 5, this has something to do with 5 again. Log 4 root 2, this has something to do with 2, right? And log 17.5. Now 17.5 isn't a really good number, so let me just write this as log 35 by 2, right? And we will now have log 7 to the power 5 by 2 plus log 5 to the power 5 by 2 again, minus log 2 to the power 5 by 2. If you play around with exponents, you will eventually get 5 something to the power 5 by 2, right? Okay, this is 5, right? 5 to the power 5 by 2. Now this is divided by log 35 by 2. Now if you look at it very closely, you will see that this 7 and this 5 will get multiplied and this 2 will get divided. So proceeding like that, we have, just let me take the powers common and outside of those logs. So we have log and third bracket log 7 plus log 5 minus log 2 by log 7 plus log 5 minus log 2. These two will cancel out and then we are left with 5 by 2, which is your answer. And the answer is C. Moving on to the next one. Right, now scrolling up. This should be pretty simple. Let's just see. We have log to the base 9, 11, log 13 to the base 5 minus log 11 to the base 3 and log 13 to the base root 5. So what we do is we just write this in log 11 by log 9 by log 13 by log 5 minus log 11 by log 3 by log 13 by log root 5. We can write this as log 11 by log 3 2 log 3, since log 3 square I'm not writing that again. So since log 3 squared equals to 2 log 3, right? So that let me just scroll this page up and we will have log 11 by 2 log 3 by log 13 by log 5, log 13 by log 5 minus log 11 by log 3 divided by log, hang on, this is 13 by half log 5. This will eventually lead to log 3, hang on, that will be log to the base 3, just give me a second, and log to the base 3 11 by 2 log 13 to the base 5 minus log 11, or is that 11? Yes, that is 11. Log 11 to the base 3 by log, sorry, 2 log 13 to the base 5. Similar terms again, these two will cancel each other out and will give 0. Moving on to the next one. All right, and we have x x to the power log y minus log z into y to the power log z minus log x into z to the power log x minus log y. This is again a cyclic term. This is cyclic. Just you can see, because x, y and z just switches places with each other, right? So to evaluate this, let this be x equals x log y minus log z into y log z minus log x into z to the power log x minus log y. Fine enough. We have this expression. Now we take log on both sides again. So we have log x equals log y minus log z into log x. Because since that was in the power, it will come down here in any case, and we can write plus log z minus log x into log y plus log x minus log y into log z equals to 0, because every term is cyclic, and you can note that every term will cancel each other out regardless of this fact that they are multiplied, right? So this becomes, since log x equals 0, and we are required to find x, we take x equals to e to the power 0 or x equals to 1, since anything to the power 0 is 1. Right, moving on, we have the last sum for today is 7 log 16 by 15 plus 5 log 25 by 24 plus 3 log 81 by 80. So we just write this down as powers and let's see what happens. We have 7 log 2 to the power 4 by 5 into 3 plus 5 log 5 to the power 2 by 2 cube into 3 plus 3 log 9 to the power 2 or 3 to the power 4 by let's see how we can write 80. We can write it as 16 into 5, so 2 to the power 4 into 5. So what we have here is 28 log 2 minus 7 log 5, 7 log 5, right? And then we have minus 7 log 3 minus 7 log 3 plus 10 log 5, 10 log 5 minus 15 log 2 minus 5 log 3 plus 12 log 3 minus 12 log 2 minus 3 log 5. Let me see if I have all the terms, and yes, we do. Now if you just work through this, you will get an answer which is equal to log 2. Very simple answer, right? So that's all for today. Thank you.